We're heading towards a future where AI assistants see and hear the world alongside you, ready to help at a moment's notice. However, prompting an agent by voice isn't always practical, like asking for a dish recommendation in a quiet restaurant, which can draw unwanted attention. We present Sensible Agent, a framework enabling proactive AR agents to adapt to user context and support unobtrusive interaction with minimal effort. Instead of waiting for you to ask, the agent anticipates your needs based on the context. It presents options unobtrusively, letting you respond effortlessly with just a simple gesture, a head nod, or a subtle sound. The framework consists of two core reasoning modules. The What module analyzes your current context to determine the most helpful agent action and query format. The How module then determines the best way to deliver that suggestion, while also enabling the most appropriate input modalities for you to use. To inform the agent's decision-making, we conducted a data collection study with 40 participants. Across 24 daily scenarios, we gathered 960 entries capturing what users want the agent to do and how they prefer to interact with it. Let's walk through how the prototype operates in real time on an XR headset. Once a trigger event occurs, an input frame and audio are captured, and along with user-specific contexts, the context parser extracts key attributes such as location and high-level activity. This parsed context is used to generate a structured context description, which is combined with few-shot example chain-of-thought reasoning. The model outputs the agent action to take, the appropriate query format, icon, binary, or multi-choice, and the recommended presentation modality, audio, visual, or both. This output is then passed to the interaction module, where the UI manager renders either a visual UI panel or audio output using text-to-speech. Simultaneously, the input modality manager selects which input channels are enabled for user response, based on context and presentation mode. In our implementation, supported inputs include head gestures such as directional tilts or nodding and shaking, hand gestures such as numeric counts or thumbs up down, and brief verbal responses like numbers or non-lexical cues such as or In this example, the agent presents a multi-choice query and the user responds with a hand gesture. So even within the same activity, Sensible Agent adapts both what to suggest and how to present it based on contextual differences. We conducted a preliminary user study with 10 participants, comparing Sensible Agent against conventional verbal prompting with AI assistants. We evaluated the system across two environments, 360 videos and AR scenarios, simulating daily activities such as reading a menu, cooking in a kitchen, or working out at a gym. We varied the context within each activity, testing how users responded when they were in a rush, socially engaged, or already familiar with the setting or task. Our findings shows that Sensible Agent reduces perceived effort as well as mental and temporal demand and increases overall preferences compared to conventional verbal prompting. We envision Sensible Agent to support users in various scenarios. In social settings like dining with a friend, speaking aloud to an agent can feel intrusive or disruptive. Sensible Agent quietly offers help in the background so users stay present and engaged with the person they are interacting with. In silent spaces like libraries, voice prompting is simply not an option. Here, Sensible Agent presents visual panels only, enabling seamless interactions without breaking social norms. In high-pressure moments like rushing to a bus, users may not have the mental capacity to ask. Sensible Agent can offer help proactively in such situations.